Hi, Professor. Wanted to go through the literacy sheet from L9 to 14. So we're looking first at L9 Part A. From here, we were asked to find the PDF of a random variable x with the exponential mu. We were then given to calculate by hand the expected value of x. So what I did in this equation here is I set up the integral, and I went ahead and said from evaluating from 0 to infinity, e raised to the negative x over mu divided by the entire equation by mu dx from 0 to infinity. From there, I went ahead and set up our integral and did a u substitution. So I called my negative x over mu my u. My du is going to be negative 1 over mu dx, and my dx is going to be negative mu du. Setting up my u substitution, I have negative e to the u du, and then evaluating that integral, I have negative e to the u from 0 to infinity. When I go ahead and evaluate that, now negative e to the negative x over m from 0 to infinity, what I'm going to get is your negative e to the infinity over m, which is going to be equal to 0, and then your e to the negative 0 over mu, which is going to be equal to 1. So we have 1 as the answer to our PDF, and that's kind of a proof of why PDF, how a PDF works, because a PDF is always going to be equal to 1, and that kind of proves it out for you, as that's kind of the definition of what a PDF is and how to get it. From there on section B, we were looking at a PDF of a random variable. We're given this equation. So from 0 to 1, we're given this equation here. So again, what we did here is we set this up, added in on our integral here. So now we have altered our equation from its original format. We've added in the x plus PDF, x times PDF dx. So we go ahead and have this new altered PDF equation. Then we go ahead and run the integral. So I go ahead and distribute it out, a little algebra work here. So we have 12x to the third minus 12x to the fourth dx. Went ahead and took the integral of this equation, went ahead and got ourselves 12x to the fourth over 4 minus 12x to the fifth over 5. When you do that out, that comes out to 3x to the fourth minus 12x to the fifth over 5. Evaluate that integral from 0 to 1, and then you're left with a little bit more algebra here. But we end up getting 3/5 as our mu there. So that was our expected value, would be 3/5. Further down, we are then asked to go over from L9 Part C. We're asked to find both the expected value and variance. So we're going to go ahead and set up first the expected value. And so from here, we're given in the given information 1 over b minus a for anytime x is in between a and b, and 0 otherwise. So we set up here first our expected value from a to b, our integral of x times b minus a over dx, times dx. We went ahead and took this constant out and moved it over, so now we're just evaluating from x. Went ahead and took the integral, so x squared over 2 from a to b, went ahead and evaluated that. So now you have b squared over 2 times a squared over 2 times 1 over b minus a, minus. So from there, once I got ahead and did a little algebra work here, b squared minus a squared over b minus a times 1/2, and took that out. Went ahead and saw that this was just going to be a perfect square, if you will. So b minus a times b plus a, so I went ahead and distributed it out, crossed out the b minus a, so now what we're left with is 1/2. A plus b is going to be our expected value. Now we wanted to find our variance. Now how do we find variance? Variance is going to be the expected value, so it's going to be the expected value plus the e to the e of x squared. So now all we need to do, we already know half of that equation, so we have found this already here, and then all we need to do is square it. We need to find what our e to the x squared is going to be. So e to x squared is going to be the from a to b, again, x squared of f of x dx. So again, this will look a little bit similar, a little twist on it there. We defined our f of x to be 1 over b minus a. So 1 over b minus a, pulled that one out, went ahead and evaluated our x squared. So we have your x cubed over 3 from a to b. Went ahead and wrote that out. So from there, you're going to have your b to the third over 3 minus a to the third over 3. From there, you have your, took that down, and then we're going to multiply that through to give you your e of the x squared. So now we have our e to the x squared here, e to the x squared here, brought that down, So variance is going to be that plus the square of our expected value that we just found. Our expected value that we just found was 1/2 b plus a, so we go ahead and square that, so you have 1/4 b plus a squared will be our variance on there as well. Moving along to 10, we were asked about a PDF taking values between 0 and 2, and is that or is that not allowed? That's not going to be allowed because, as we know, a PDF is always going to equal to 1. So what we did is set up a simple interval here from a to b, f of x dx is going to be equal to 1. So when you go ahead and evaluate from 0 to 2, x is dx, you go ahead and evaluate the integral x squared over 2 from 0 to 2. What you end up getting here is going to be 2 minus 0 is going to be equal to 2, and that's not equal to 1. It cannot be a PDF. It cannot equal it. It has to be equal to 1 at maximum, so that cannot ever work. How would we know that? We know from any continuous moving variable that we has to equal 1. Kind of answered that already. So now on B, we're looking at setting a number z, so any random z from 0 to 2, and how is this going to work? How can we create a PDF that would work? So again, set this up. Set up z times our x here, evaluated our x squared over 2 from 0 to 2, and then equals to 1. So then we went ahead and said and evaluated that. And what we found here is that z would have to equal 1/2 in order for this function to work properly. So you'd have 1/2 x dx, so that this PDF would be equal to 1, because that's the maximum that it could equal. From here on C, we are then said given a random variable here, b, so from 0 to b of 2x. So now what do we do? Well, now we're posed to this problem trying to figure out b, figure out where we're going from instead of anything in the middle here. So now we evaluated our 2x, we have x squared from 0 to b, so we have b squared minus 0 squared equals your b squared equals 1, so we know that b has to equal 1 in this scenario, and that again would produce a correct functioning PDF function there. The other things that we needed to go through here was question 12. Question 12, as I flip the sheet on the other side, was going to be asking about loss amount. And so what we did from here is what we found. We needed to find our cumulative distribution function. So we found our derivative of our equation here. So we did from 0 to 3 x over the given equation, and there's the given equation. So we go ahead and multiply our x straight through. So that gives us this new equation here. Go ahead and evaluate that integral. So we have our 4/9 times your x to the third over 3, which is going to give you I'm sorry, I did that incorrectly on this side here, but it's correct over here. So once you go ahead and evaluate the integral, you have 4x to the third over 27 minus x to the fourth over 36 evaluated from 0 to 3. Go ahead and bring these in. This is going to be 4 minus 9/4 minus your 0 on the side here is going to be 7/4. My apologies on the clerical error there, but this does translate down. So you can see once you evaluate that integral, this is what you get, and evaluate it from here. Looking at 14, we're looking at insurance. This is kind of funny because this ended up being a very similar problem. So again, we have a similar equation given to us here. Add in our x to evaluate that CDF, and then from there we have we've gone ahead and distributed out that x across the equation. We've gone ahead and taken the evaluated that integral there. So now we have a similar equation of 4/27 x to the third minus 136 x to the fourth from 0 to 3. Evaluate that down, so you get 4 minus 9/4 is 7/4 is 1.75 million was the group insurance policy that we're looking for there as we evaluate that integral from 0 to 3. So that was the literacy sheet from L9 to 14 redone, and I'll take pictures of this math as well, and I'll correct this a little bit here so that it all makes sense. But I've gone through it, and all of them are now assured correct. Thank you.